Modeling quadratic functions with the TI-84. So what we're going to do is we're going to write equations for real-world situations that fit quadratic models. So you could definitely do this by choosing 3 points and putting it into a system of equations and solving with a matrix. However, since it is real world, not everything fits perfectly to a quadratic, so we're going to use a regression function instead. So up at the top, we have our steps to do this into our calculator. So the first thing we're going to do is enter the data, and then we're going to find the curve of best fit. So let's look at example 1. So the table below shows the height y of a competitive water skier x seconds after jumping off a ramp. Letter A says write a regression to model the data. So if it asks you for a regression, basically that just means it's asking you for an equation. So what we're going to do is we're going to put this table into our calculator. So this is step 1. We're going to enter in our data. So we're going to press stat, and then we're going to press edit. And then we have L1 and L2. This is list 1, this is list 2. So basically, we're going to put all of our x's into list 1 and all of our y's into list 2. So we're going to put 0, enter, 0.25, enter, and you can use your keyboard. You just can't use your keyboards for negatives. 0.75, enter, 1, enter, 1.1. Once you're done putting in your x's, you're going to arrow over to L2, and you're going to do the same thing with your y's. So 22, 22.5, enter, 17.5, enter, 12, and 9.24. And you should have the same number of entries in L1 and L2. If this has more or less, then you missed a number somewhere. Make sure you double check your numbers. Once you have your entries into your calculator, you actually don't even need this bottom step. We don't actually have to quit. We can just go straight into calculating. So now we're going to find the curve of best fit. So in this case, we're going to find the quadratic that models these numbers. So we're going to press the stat, and then you're going to arrow over to calculate, and you're going to use the down arrow to find number 5, quadratic regression, and press enter. Now, this is all what it should be. You should have your X list as list 1, because that's where we placed our X's, our Y list in list 2, because that's where we placed the Y's. We don't need to worry about anything else. We just need to press enter until we calculate down at the bottom, and it will give us our equation. So it gives us the layout, it gives us our A value, our B value, and our C value. So when we write our equation, it's going to be y equals A, which it says is negative 16, x squared, plus b, so plus 6x, and then plus c, which is 22. So this is the equation that best models this data. So for letter B, what is the height after 0.5 seconds? So seconds is my x. So I'm saying that x is equal to 0.5. So use your regression equation from part A and substitute a 0.5 wherever you see an x. So negative 16 times 0.5 squared plus 6 times 0.5 plus 22. So we can easily find the y by simplifying this right-hand side by hand, or we can use the help of our calculator. So we can type this in. Well, we don't need the y equals, we just need to start at negative 16, parenthesis, 0.5, close parenthesis, and then here's the square button. And then we're going to do plus 6 parentheses 0.5, close parentheses, plus 22, and press enter. And so we come up with a y value of 21. So what that means is you were 21 feet in the air half a second after your jump. Pause the video, try the bottom example, try example number 2. And here's what you should have had for number 2. Now, when you do your lists and spreadsheets, when you press stat, and you go to edit again, you already have values inside of these lists. To easily clear them, you're going to scroll up and where you're highlighting the title, you're going to press the clear key and then press enter. And that easily clears out all of your values. So one more time, go to L1, highlight it, press the clear key, and then enter. And that clears out your lists very quickly. Now, let's talk about what happens if I don't give you a full table, if I give you just a description. So Brandon is vacationing in Hawaii and is doing cliff diving. His friends took some data of his path. The cliff that Brandon jumped off of was 480 feet above the water. After 3 seconds, Brandon's height was 390 feet above the water. Then he was 296 feet above the water 4 seconds into his jump. So letter A, write the quadratic function that models Brandon's height y after x seconds. So it is our job to create a table. Well, my height is my y and my x is my seconds. So when you're writing these coordinates, it's going to be the seconds, comma, the height. So let's see if we can pick out our 3 coordinates. You need at least 3. So I see here that it says after 3 seconds, Brandon's height was 390 feet above the water. That's one coordinate. So one of the coordinates is 3, 390. Then it also says that 296 feet above the water 4 seconds into his jump. That is another coordinate. However, be careful. This 296 is not the x because that's 296 feet, which is my y. The 4 is actually my x. So be careful that you're writing these coordinates in the correct order. And finally, the last point is here. The cliff that Brandon jumped off of was 480 feet above the water. That's his starting position. So at time 0, he was 480 feet up. These are my 3 coordinates. So now we're going to take these 3 coordinates and we're going to put them into the calculator to help us find that regression. And we do that by making a little table out of these coordinates. These are the x's and these are the y's. So x's go inside of L1. So let me start this over. So we press stat and then edit. And now we put in our numbers 3, 4, and 0. Arrow over to L2. And we're going to put 390, 296, and 480. The order of these does not matter. So for example, if you had written this coordinate first, and then this one, and then this one, that doesn't matter. What matters is as long as the 3 and the 390 are together. The 4 and the 296 have to stay together. So now we're going to go to stat again and calculate and scroll down to quadratic regression. This is all okay. Just press calculate. And we get an equation of y equals negative 16x squared plus 18x plus 480. Now, you're probably thinking, why is everything a negative 16 in the front? Well, if you ever talk about anything being thrown or projectile motion, that negative 16 talks about gravity. So if you're doing anything that has to deal with gravity, like jumping or throwing a ball, anything like that, you're going to have either negative 16 if it's feet, or you're going to have 9.8 if it's meters, but it needs to be negative in the front because most quadratics look like this for real world. So letter B, what was Brandon's height 1 second after he jumped? So 1 second is my x, and we're going to substitute this in. So negative 16 times 1 squared plus 18 times 1 plus 480. You could use your calculator, but this one isn't too bad. I know that 1 squared is 1, and negative 16 times 1 is still negative 16. 18 times 1 is 18. And then when you add all these up, you get 482. So he was 482 feet above the water after 1 second. So, last example. Take a minute, pause the video, and see if you can find the coordinates that you need for our table. And here's the coordinates that you should have had. 20, 25.2, 50, 30.4, and 70, 25. Again, the order you have them listed does not matter. So now we're going to plug these into our calculator to help us find the regression. Pause the video, see if you can figure that out. And here's the equation you should have had in your calculator. Now, there's a lot of decimals here. We don't need all the decimals. Most times, rounding to 2 decimal places is plenty. But I do mean round. Don't truncate your decimals. What I mean by that is don't just chop it off after 2 decimal places and call it good. So for letter A, if I were to round to 2 decimal places, that means I want it to be this 0. I look at the 3rd decimal place, and I know that 8 is higher than 5, so that 0 is actually going to round up to a 1. So I have negative 0.01 x squared. Now for the B, 2 decimal places is the 9. The 4 is less than 5. So we're going to round that 9 down to stay a 9. So this will be plus 0.79x. Then 12.866. If I want 2 decimal places, I'm going to look at the second 6 because that 6 is above 5. That first 6 rounds up to 7. 12.87. Pause the video, see if you can answer letter B. So you should have had 26.07 miles per gallon because the 55 miles per hour is the x coordinate.